In this lesson, you will be optimizing your IoT device for long-term stability and performance. After successfully integrating and testing the IoT system, it is essential to refine the project. We will be addressing potential issues such as performance bottlenecks, sensor accuracy, and network stability. You will be fine-tuning various aspects of your system, including sensor readings, refresh rates, power consumption, error handling, ensuring that the system runs smoothly and efficiently over extended periods of time. By the end of this lesson, you will have a stable and optimized IoT device ready for real-world applications and deployment. Now that you have tested your IoT system and confirmed basic functionality, it is time to optimize it for better performance and stability. Optimization ensures that your device can run for extended periods of time without crashing or becoming unreliable. This includes managing sensor accuracy, handling data efficiently, optimizing refresh rates, and ensuring that the Wi-Fi connectivity remains the same over time. In this lesson, we will go over several keys for optimization. We will help you enhance the reliability and performance of your IoT device. Let's start with the optimization of sensor readings. Your IoT system collects temperature and humidity data from the AHT10 sensor. To ensure that the readings are accurate and don't fluctuate unnecessarily, consider fine-tuning the sensor intervals. Continuously querying the sensor can cause data fluctuations or inaccurate readings. It's better to adjust the interval between sensor querying based on your specific use case. For example, if you're monitoring room temperature, a reading every few seconds is typically sufficient. You can also consider applying smoothing algorithms. Sensor readings can be prone to small fluctuations due to different environmental factors. To improve stability, consider implementing a simple smoothing algorithm, such as a moving average, to reduce noise in the sensor data. This will provide more consistent values over time. Another optimization option is managing the refresh rates of the TFT display. The TFT display updates in real time to show sensor data. However, rapid refresh rates can cause screen flickering, slow down the system, or drain power. Optimizing the display refresh rate is key to achieving a smoother operation. For example, update only when necessary. Instead of updating the display every loop cycle, you can set the display to refresh only when there's a significant change in the sensor data. This reduces the load on the system and minimizes the flickering. You can also control the screen brightness. If your IoT system runs on battery power, you might want to reduce the TFT display's brightness to conserve energy. Some displays allow you to control the black light brightness via code. Dimming the display when the system is idle or when the light conditions are low can help extend the battery life. There are also optimization options for the web server stability. Wi-Fi connectivity is crucial for serving sensor data over a web page, but unstable connections or network interruptions can cause the system to fail. Your IoT system should be able to automatically reconnect to Wi-Fi if the connection drops. This is essential for long-term deployments where the network reliability cannot be guaranteed. You should also avoid overloading the server. The ESP32's web server has limited resources. If too many clients try to access the server at the same time, the system might become unresponsive. To prevent this, you can limit the number of clients or implement a simple load management strategy to handle requests more efficiently. To further improve the system reliability, you will need to implement error handling and ensure that the system can recover from unexpected issues. If the sensor fails to provide data due to a temporary issue, such as a disconnection or an environmental interference, your system should be able to handle this gracefully instead of crashing. Implement a simple check in the code to check for the sensor's status. Another viable option is implementing an automatic system reset. You can use the ESP32's built-in watchdog-timer, or WDT, to automatically reset the device if it becomes unresponsive. The watchdog-timer ensures that the device can recover from critical failures without the need for manual intervention. By applying these optimization techniques, you ensure that your IoT system runs smoothly and remains stable over time. Your system will perform efficiently with optimized sensor intervals and data smoothing techniques. will update the display reliably without unnecessary flickers or refreshes, handle Wi-Fi connectivity issues gracefully, automatically reconnecting when needed, and manage resources efficiently to prevent a system overload and system crashes. Optimizing your IoT system for stability is a crucial step in preparing it for real-world applications. This lesson went over how to fine-tune sensor readings, manage display updates, handle Wi-Fi connectivity, and implement stability measures like error handling and watchdog timers. These optimizations will ensure that your system will operate reliably over extended periods of time, making it more robust and ready for deployment. By integrating these stability measures, you are preparing your IoT project for real-world usage, whether in home automation, environmental monitoring, or more advanced IoT applications. These optimizations are optional though, as they are tackling more advanced concepts and are not required to finish this project. With a stable, optimized IoT system, you are now ready to deploy your IoT project with confidence.